Hi, this is Lab 1 for the Mechatronics class, and in this lab we are going to learn sensor actuator interfacing and calibration, and also do some things with the LCD display. The first steps in these labs are we give the motor a step response for some uniforming varying voltages, and we measure the TAC and the encoder output for these voltages. Based on these input voltages, we um, make or draw relationships between the input voltage supplied and the encoder output and the TAC output, which gives us the tachometer constant and also the constant for the encoder, which we call K for this lab. Once that is done, we go ahead and explore nonlinearities when we plot graphs of the input voltage with the encoder output in RPM. For extremely low voltages, we start seeing nonlinearities and flat tops in the curve, which is a sign of the dead zone of the motor, and that is interesting to explore. Later, we hook up a LCD display and just play around with it for a few minutes. That's it, and my friend Amin will now talk to you about the details of this lab.
Hello everyone, this is lab number 1, and basically in this lab we're gonna use the encoder. We're gonna use the tachometer and the encoder. Let me show you the connections for the encoder. If you see the Quantum 4, those are the encoder inputs. In this lab we're gonna use just one input, and this is gonna be number 0. You take the cable right here, this one, and just connect into the input number 0, and this is in the motor we have the encoder input, so we just connect the cable right here and we are ready to work.
One thing you should note about this is that this cable goes from the motor directly to the board, because this is a digital input, so it just goes directly to the board, doesn't need to go through the power amplifier.
Okay, and also we need to do some changes with the block that we worked before. We need just to add this new block. This is the encoder input and an output, of course, and also instead using a sine wave, we're gonna use a step function. And let me find the Simulink. If you are confusing how to find the encoder input, you just need to go to Quantum toolbox and just click in Quantum Q4 series, and right here, if you see, this is the encoder input. Just click on it and then just place into the project like that, because I have one already. And for the step input, you go to sync to source, I guess, yes, source, and you take the step input. For the step input, inside we're gonna use the amplitude. It's gonna be the same as before in lab 0. We're gonna use the same amplitude. For this lab we're gonna change those values. In final value, you just write the constant that you're going to use for this lab. The purpose of this is because we don't want to change every time. For example, -5. When you're going to simulate the code, we don't want to change every time the value. That's why we are using a constant.
A variable, you mean?
What?
It's a variable, so you can change it.
Yeah. For the encoder input, inside we're gonna use the channel 0. As I showed you before, we're gonna use channel 0 for the encoder, so we don't have to change anything. And for the analog input inside, we're gonna use channel 3. This is gonna be S4 in the power module, and we are ready to simulate. Oh, another thing is, for the stop time in this simulation, this lab, we're gonna use 4 seconds. So the constant is gonna be 4 seconds. So this is gonna be the stop time. After 4 seconds, the simulation is going to stop. So remember that after you done with the block, with the simulation block, the simulating diagram, you first has to run the code. It's right here. This is the code that we're going to use for this lab. Let me tell you that this lab, the purpose of this lab is to know the linearity of the system. So the first part of this lab, we're gonna test some amplitudes. It's gonna be just -5, -4 until to get like 10 values, right? We're gonna have 10 values. So, and basically it's the same thing. So the only thing that you notice that we need to add another line here because we are using the encoder, and we need to save the encoder output right here. So as before, we use in lab 0, we just use this code to save the data from the tachometer. In this lab, we're gonna use also, we need to take the data from the encoder. And remember that this name must match with the output of the tachometer, and this one has to match with the output name of the encoder. So right now we are ready to simulate the problem. After you have the code already set, this one is gonna be the code to test the linearity of the system. After that, you just need to run, because you need to run first the program in order to run the simulation block, and I already did. I just need to simulate the block. As you see, it's really quick, but